Okay, last video of the chapter. Let's go over what we've learned over the last few days. We learned some rules about taking the derivative of an exponential function. We said if it's any number besides e to a power, it's just that same thing times the natural log of the base times the derivative of the power. That's the chain rule part. We said if it is e to the power, then it's just e to the power times the derivative of the power, because the natural log part would be 1 because the base is e. Log base a of u, you would have 1 over the stuff times the natural log of the base times the derivative of the stuff. And if it's natural log, so the base is an e, it would just be 1 over the stuff times the derivative of the stuff. At what point on the graph does the tangent line have a slope of 21? If we're talking about the tangent line having a slope of 21, we need the derivative. The derivative would be 2 to the t times the natural log of 2. And we want to know where that equals 21. So to solve this, I'm going to divide by the natural log of 2. So I get 21 divided by the natural log of 2, and I am using my calculator for this, is 30.297. To figure out that value, I'm going to natural log both sides. The t drops down, so I have t times the natural log of 2 equals the natural log of 30.297. So when I divide by the natural log of 2, I get 4.921. Now that would be the x value of my ordered pair, but to calculate the y value, I'm just going to take this and I'm going to plug it in to the original function. Not the derivative, the original. So 2 to that number minus 3 would be 27.297. And that is the point on the graph. Now, some of you are thinking, how come having the t wasn't, can't see what I wrote. How come having the t wasn't good enough? Because it asked me for the point on the graph. I'm going to give you a second to read what I wrote. We actually did this one in our notes not too long ago, so it may look familiar to you a little bit. Just take a second and copy that down. The second thing that we learned at the end of the chapter was L'Hopital's rule. If you try taking a limit and plugging in your number, and you get 0 over 0 or infinity over infinity, these are called indeterminate forms. In that case, you just take the derivative of each function, the top and the bottom, and you try again. So let's look at an example. If I try plugging in 0, I get 0 over 1 minus 1 minus 0, which is 0 over 0, which is an indeterminate form. So I'm going to do the limit, and now I'm going to take the derivative of the top and the bottom. The derivative of the top would be 4x. The derivative of the bottom would be e to the x. The derivative of the 1 is 0 minus 1. Now if I try plugging in 0, I get 0 over e to the 0 is 1 minus 1, which is 0 over 0 again. So try the derivative again. I get 4 divided by e to the x. Now if I try plugging in 0, I get 4 divided by 1, which is just 4, and I'm done. That's it. See you tomorrow.